Today's businesses are on a vigilant watch for threats in an ongoing cyber war. It's time to get real-world solutions to protect and secure your valuable business information anytime, anywhere. Welcome to Cybersecurity America with Josh Nicholson. You're about to gain special access into a world of restricted information and a backstage pass to the inner sanctum of cybersecurity operations. Here's your host, Joshua Nicholson.
Now, don't forget to hit subscribe, comment, share, and turn on those notifications so you don't miss an exciting episode.
The one big thing that's been focused on at the Deep CTI desk is the MoveIt managed file transfer vulnerability, which has now been listed as CVE 2023-34362. This vulnerability affected Progress's MoveIt file transfer software. And when taking a look, we found that it had been exploited as early as May 27th. And so what it looks like happened here is over the Memorial Day weekend, threat actors already knew about an existing vulnerability within this software, had been conducting scans for quite some time, and then started extracting files from different organizations on or around the Memorial Day holiday when they knew that there was going to be limited staffing. This goes along with a lot of the tactics, techniques, and procedures that we identify when it comes to different threat actors, primarily the idea of targeting software that they know is widely used so they can cast that wider net and get as many victims as possible. In addition to that, understanding the holidays that we celebrate in different countries, primarily like the United States with Memorial Day, or other countries and their different holidays when staffing will be low and it'll be less likely to see some of that reconnaissance activity caught. Then once they deployed, they started extracting as many files as they possibly could, especially targeting ones that they thought were particularly sensitive. And it looks like, according to Microsoft and Mandiant, they've identified Clop ransomware as being the threat actor who is targeting these different organizations. And then Clop had acknowledged that by stating that organizations that had files removed should reach out and contact them, which is the opposite of what the expectation generally is. Once you see files extracted from a threat actor, an organization typically waits to see some sort of extortion email that lists out either communications or the demands that are made by the threat actor for what you need to do to either unencrypt your files or ensure that your files aren't publicly posted. There's a lot of assumptions that can be made as to why Clop might be requesting victims come to them. Some of it could be because they have such a large cache of information that they just don't have the manpower to actually go through it and individually contact their victims. And additionally, it could also be a way of being able to extort victims who may not have had anything actually removed or anything sensitive, but are in fear because they maybe saw some anomalous activity or they were exposed and perhaps they don't have a mature enough IT infrastructure to fully know whether or not they had been compromised. But what this does show is why there needs to be such a focus on the attack surface reduction aspect of your network, understanding what is out there and internet exposed. What are you doing to heighten that type of monitoring and look for any sort of anomalous activity? And in addition to that, what are you doing in the event that you do have data extracted? Do you have a playbook that is going to explain to your staff and the measures that you're going to take and the appropriate people who need to be involved? What stakeholders need to be in the room in the event that you have data that's extracted and you may have to actually start dealing with a criminal threat actor to ensure that sensitive data doesn't end up on the internet? These are the types of questions that you need to ask yourself and within your Cyber Fusion Center or your IT department to know exactly which ways you need to shift to ensure that you're prepared for this type of incident to occur. It will make things a lot easier down the process and ensure that you don't deal in emotions and you deal because you have a set policy that you are going to follow, how you're going to mitigate the threat, how you're going to minimize the damage, what your communication mechanisms are, and then ultimately, what are the strategies you're going to use when you have to deal with a threat actor who is going to be demanding a ransom from you. But that's been our primary focus for this week, and it does encapsulate a lot of what we've discussed in previous podcasts. Thank you so much. Back to you, Josh.
Welcome to Cybersecurity America podcast. Today's episode is going to be on innovation in the cybersecurity world. What are some of the newer startups today? And what are some technologies really to keep your eye on and keep focused on? And today, in order to be able to give us some insight into that and to be able to have these conversations, I brought on John Bagg. Now, John Bagg is the co-founder and the CEO of the AI cybersecurity startup Salem Cyber. Now, John has more than a decade of experience in helping top commercial orgs implement cyber technology and threat detection programs. That's interesting. You have a great background, John. How are you doing today?
I'm doing great, Josh. Thanks for having me.
Now, did I miss anything on your bio? I knew you got a pretty extensive one. It was a short one, but anything else you want to highlight?
You and I used to work together, so that's how we know each other.
Sorry for the experience.
Yeah, no, you're a good colleague. I don't like the long bios. I've done some interesting stuff. A lot of it I can't talk about, but yeah, technology, blue teaming, big data, analytics, it's my world.
And I know you left Booz Allen, you started your own cybersecurity company. It was really focused on that cutting edge. So tell us a little bit about Salem Cyber and what do y'all do and what problem are you solving?
Yeah, so we have a technology we call a virtual cyber analyst. The problem that we're trying to solve is this one of there's too many cyber alerts, right? Anybody who's been in cyber will recognize that problem. And that was my world in managed services and working directly for big companies trying to detect threats in their environment. There's just more signal to look at than anybody has time for. And I think what I realized doing that work is that any one of those things, any one of those notification that goes off has an answer, whether something nefarious or normal business operation is happening. And almost every case, a person can figure out what that answer is. They just can't do it enough of the time, right? There's just not enough people cycles to do the number of investigations that would be required to give you that like full coverage, take advantage of all of these detective capabilities that everybody's implemented. And so what we're trying to do with our virtual analyst is say, if we don't have a process problem, we have a scale problem. How do we bring advanced technologies such as AI to bear to replicate that investigation process and do this triage analysis at scale and help organizations figure out what actually requires their analysts' eyes right when it's happening, push that stuff to the front of the queue and give them some advantage so that they can process a lot of signal and focus their time more specifically on what really matters.
Yeah, that seems to be the key is the noise ratio that we have in alerting and any of these functions that you want to really be able to have cybersecurity SMEs be able to do cybersecurity work and just be able to automate some of that more mundane things. And that on a lot of the sides, a lot of security operations centers we're in is that the alert fatigue is real. And what happens is not just the fatigue of responding to these alerts, it's almost numbs you to what that event is and is it actionable, and to the point where you just ignore it. And that's where we definitely don't want to be at. And I think that's the problem you're trying to solve there with your platform is to help with that alert fatigue.
Yeah, people get bored pretty quickly, and it's a truism that we don't always talk about, but when somebody comes into cyber with not a lot of experience, we stick them on the queue to look at these alerts and learn the ropes through the grunt work of the ins and outs of, is this a problem? Is this not a problem? And once they become good at that job, they all of a sudden become qualified for a lot of other more interesting type of work. And so the net effect of it is not only do you have people who are fatigued in this job, but they don't have a lot of tenure doing the job, because as soon as they get 6 months, 9 months, 18 months into it, they move on and start doing more impactful or interesting work to them. And so not only do you have fatigued analysts, but you've got your most junior people doing this really important job of identifying out of the data stream what those more senior people need to be reacting to.
Yeah, so it's almost like a co-pilot in many ways. We're Jarvis in the And remember in the movie in Iron Man, and I always foresee that. Wouldn't it be great when you're working on your workbench and you go, Jarvis, can you raise the temperature 5 degrees? And no, you don't have to stop and do that. And so it's almost like this AI assistant that you're using to help get through the noise. Like in a SOC world, I'd really like to know, hey, is this event that's going off? Did that ever occur before? Does it really indicate something malicious? Is it that Linux machines never talked to the internet before? I'd really like to know that. Those type of anomalous variables or situations in the network is much easier to do cybersecurity on than, okay, I got 5,000 alerts of 1007 event ID, and I have so many of these. And what does that mean with these different atomic elements? And it would just much easier to go, hey, this box is beaconing outbound. It's never done it and it's not supposed to. And that to me is much more actionable than just the plain alerting. I guess that's what you're talking about as well, is
Yeah, all of those questions that you asked have very discrete answers, right? I can know whether this has talked to the internet before I have the visibility. I can know what kind of information is processed on that system, what kind of applications it runs, when the last time it was patched, all of the things that you probably would want to know as like contextual elements in trying to make that decision. And when you talk about innovation, right now the strategy is automation. So if I know how to do all those things and I do them enough, I can automate the task of going to pull that information together and put that into the package. So when the analyst looks at it, they don't have to spend the time to go find that piece of context that was relevant for them. But I think what we've discovered is that there's two challenges there. One, there's this challenge of if I don't do something enough, it's not worth automating. So there's a bunch of tasks that I always want to resolve IP addresses to system names, right? So let me just go ahead and do that. But some of the questions you might ask in the course of an investigation might be totally bespoke to that particular situation. And so it wouldn't have been worth it to put an automation play in place. And you get enough of those situations, there's this kind of like long tail of tasks that are too infrequent to automate, but together represent a huge body of work. And so you hit this point of diminishing returns with more automation plays. And then the second problem is that the automation has brought together this information, but what we're trying to do is actually analyze all of that information that's been brought together and actually make the decision. So go one step further and say, I'm going to bucket this as one of those situations that's likely normal business activity, or a situation where this does really require a potential response and needs to be escalated up. And so when you go one step further, all of a sudden you can take the benefit of all this information that you've collected and actually make a decision. You can further add scale to the process because you've reduced the number of points at which you need a person to go in and make that decision that is relatively routine.
That makes sense. I think when you talk about diminishing returns on automation, yeah, I think the overhead of maintaining automation becomes a new problem. When you think is if just to maintain all the automations and the changes of them and so forth takes another person. So it's almost like you've lost the benefit of automation and you just move the complexity of keeping up with it to another person on the IT team and not really having a real addressing the needs. I think that's what you're saying. Be careful with your automation. Make sure it's actually doing what you need in order to scale and not causing more problems in itself. Is that sort of what you're saying?
Yeah, and I think early demonstration of like task AIs have shown that if you can define what automation capability you have, you can allow an AI to make a decision on which automation to run when and potentially with what parameters to answer a particular question. So you can get the benefit of being able to collect all this information, but not actually have to do the last mile of, I'm going to automate running this particular search in my SEM solution. You can create a connection, the ability to query some parameters around what can be done. And then the AIs can actually decide with some assist from people what that query it's going to run is and how it's going to interpret the results, and then add that information to the investigation. So you're almost automating the process of creating net new automations with these AI models. And that's a primary value driver that we're trying to bring to the table.
All right. And how would be the best way to implement something like that? So you would have your logs flow into a data lake and then use AI to pick up logs from a data lake. How is the best way that you implement a solution like that?
best is always a fraught question, right? I think 10 years from now, I'll be able to answer that very specifically. The approach that we've taken is a little bit different than that. We are focused on starting with the actual alert. So we take alerts from SIM platforms and other detection platforms and the information contained within them, and then use the connected tissue to other systems to query for additional context within the scope of what's already been detected. And the thesis is really two things. One, we don't want to resolve the big data problem. It's costly, it's complex, and there's a lot of solution out there that's already aggregating all of your data. So we don't need to do that for you as well. And then I always forget the second point. But anyways, so we're focused on taking the alert and starting that as the investigation point. And then, sorry, the other part of the thesis is we already have so much ability to detect that we're not really focused on using the AI to detect that like N+1 alert. We're using it to reduce down what all of your other detection investments have already focused on. So other people are going to be out there and they're going to help you find a new creative way to detect ransomware or detect some state actor that you're really worried about. What we're trying to do is then take the reflection of that, the alerts produced by that analytic or that capability, and then decide, no, these ones were actually okay for these reasons, and this small subset is actually what you should be looking at.
Interesting. And that gets down to the alert fatigue and everything and starts to resolve the issue and then the spikes and so forth. So what are you seeing? I just had an episode on cloud computing and security with Martin Bro. And he was talking about how we both noticed in the industry there was this move to cloud over the last decade. But then there's actually a move from cloud back to part of it being on-prem into a hybrid, which that from time to time, where he was talking about where you're going to start to see infrastructure local again. Now, implementation of AI had on another podcast, he was talking about how you can have your own instance of AI and it's not plugged into the open AI API. And so you can have like your local instance that you don't have data leakage problems and so forth. So is this kind of where we see the future, where there's this hybrid cloud, but then you have AI in the cloud as well as AI on-prem because you want to protect it physically? And I don't know, I'm trying to see where the future goes in this. So for instance, you and I were talking before about virtual employees, right? Where I can see this VM ESX chassis where it's a virtual machines, right? Instead of a DNS server, it's Betsy, your accountant, and that AI model is very good at accounting and scheduling and so forth. And then you almost have 10 or 15 virtual employees that are really AI bots that do specific tasks. So when I go out to market and I want to start a company, I don't actually have to physically hire a lot of people. It's all these AI personalities, so to speak. I don't know. Does that sound crazy or?
No. The notion of naming your AI and then keeping it in your ESX cluster that's in your closet is a little bit funny to me. But I think there's a lot of factors here. I also think that the AI is going to be a platform shift, and it's going to cause people to rethink some of the migration to the cloud approaches that they're taking for a number of reasons. The first is very fundamental, that there's only so much of this high-powered compute available, and there's going to be more and more competition for access to it. So these models that have captured everybody's attention right now, these large language models, are large, and they're very hard to run on the edge. They really require these high-powered, high-memory graphic chips, primarily like the NVIDIA stuff that you hear about all the time. The big models are 65 billion or 70 billion parameters. And the rule of thumb is that you need 2 gigs of memory to run for every billion parameters to do inference, which is when you ask the model a question. And so there's very few companies that build these compute components that are spec'd to be able to work with models that big. And so if you're a big organization that's going all in on AI, you're looking at your cloud strategy and you're going to say, I have my own model, it's really big, I want to run it. am I going to have capacity with my cloud provider to actually get access to those machines necessarily to do this work? And that becomes a question, becomes a risk. Okay, maybe now I want to move to on-prem infrastructure where I can buy these assets and then I know I have that capacity. This is before cloud, you had to buy your own computers because that's how you guarantee capacity. Then there was so much capacity in the cloud that went away. The GPU shortage is going to bring that back. The other thing that's really interesting is the trust and safety angle. So I was reading an article in Gizmodo yesterday about how supposedly Google was telling engineers not to use ChatGPT or Hub Copilot for any code or anything like that because they're really worried about who can see that information, what kind of information is going into these systems, and who on the other side is reviewing that information. From an OpenAI perspective, they are looking at the regulation angle, and their trust and safety view is how can our system be abused? And so they're going to want to have people reviewing the questions and the prompts that are getting asked of their services so that they can ensure that there's no abusive or what they feel is abusive behavior. But what that means is for an organization that's relying on those APIs, you're all of a sudden giving up control over who has visibility on that data. And so if you're worried about using sensitive information and proprietary code or other bits of proprietary information, you might all of a sudden say like, hey, it's not in my best interest to leverage these API models that are available through these services such as OpenAI. And what I need to do instead is stand up my own infrastructure so I have complete control end to end on that information, which is another thing that's going to push the biggest enterprises into their own infrastructure. They just want more end-to-end control. And we don't know where like the regulations are going to net out, and we don't know where these services are going to net out in terms of how much privacy control and how much visibility and auditability there'll be over that information. And we don't know, for instance, if I am working on a project in GitHub and I have GitHub Copilot and I've got an API key in there and it consumes that and uses it as a training element, will my API keys be recommended to another user when they're asking how to build this service? So there's just all sorts of trust and safety office issues with these APIs, and it's evolving so quickly that the answers to these questions seemingly are changing all the time. And then regulation hits and they change again. So I think there's a lot of concern, and that is again going to push people like, okay, maybe I need to have my own racks with my own infrastructure, and you need a lot of compute to run this stuff. So you're going to need a lot of these things. You're going to need a lot of space, and all this work we've done in security to protect the cloud. Who knows in 3 or 4 years if we're backtracking on a lot of that because everybody wants to have their own data center again.
Yeah, it'd be interesting. It started from this field and it was mainframes and dumb terminals. And then it went to distributed computing, and then went to thin clients and Citrix. So back to a central piece of hardware, then back to nodes. It goes back and forth, these big shifts. And we used to call these dynamics, like we would move into cloud and that would be it. Everything would be in the cloud. And now you see it go back to on-prem because of usage. So it's interesting to see those trends and how it goes back and forth. At the same time, trying to do managed detection response in the cloud when they're serverless. There's no network IDS sensor you could put in front of serverless. And so there's just all this different pieces where the dynamics change. You move to cloud and a lot of the controls weren't anticipated. Somebody didn't think about, oh, okay, now this is how I need to do it in this new world. And I think it becomes a challenge. One of the things I learned from the last podcast that I had an AI expert on, he was talking about delusion rates. Like AI can get delusional, where you have this model, but it's its delusion rate is this. I was like, hold on, what's a delusion rate? Yeah, it just pretty much doesn't know the answer and freaks out and does something crazy. I was like, oh, wow. And now I think you would have to have these trained models where they have, I don't know, ratings on your delusion rate, like the Better Business Bureau. Hey, this model is somewhat delusional. And then what you were saying is having data that's not shared with others. He said you can have it set it to forget certain elements over time, where it's forgetfulness or don't remember or use this data anymore after this time period in those models. So it seems like it could be pretty complicated. Huh?
It's an emerging science for sure. In terms of open source models, service Hugging Face has a leaderboard of LLM models, and they've got a couple of different scoring mechanisms that they use. So you can get a sense of relative performance against each other. But yeah, this type of model, its underpinnings, a neural network, has been around for a long time. And then in 2017, Google comes out with this paper that basically describes a way where you can get these models to focus on certain elements better. And all of a sudden, that created the capability for this generative text that seems so magical to everybody. But at the end of the day, it's predicting the next word, one word at a time. And so what happens is if its focus is off or any number of factors, it can start predicting what seems like the next best word, but based on all of the different input that it's had. I'll give you an example. I looked up Salem Cyber in Google Bard, and it produced this really accurate information about a company, including like how much money we had raised that was accurate to last month, except for the fact it made up a bunch of investors who invested in us, right? And from its perspective, normally when I'm doing these company profiles or when I'm reading company profiles, it has a set of investors, right? And it probably predicted based on our location and other factors that this would be the most likely word to put here, which is the name of a relatively local investment firm. But it's not rooted in reality, right? It's rooted in that was the next best word to put in that particular slot. But I say that to say the science here is emerging. So now that this delusion problem is being defined and codified, you have new research coming out on how to combat delusion. And I think Harvard just released a paper this week, or at least I heard about it this week, talking about a new structure on how you can reduce delusion, improve your delusion score. I think that's the other important thing to remember is that it's an emergent field. There's a lot of excitement, which is driving a lot of activity and visibility to it, but it's certainly not a perfect science today. And we're just going to see a lot of evolution, iteration over the next couple of years until we hit that commodity version of, okay, this is the thing that basically works for everything, right? It's when you hit like the iPhone 10 and all of a sudden every iPhone looks the same because they figured it out, right?
Yeah.
Eventually we'll get there, but we're not there yet.
Yeah, and that's interesting. I think wasn't in the news, they had a lawyer who got admonished for putting a briefing together through ChatGPT and it referenced the wrong cases and it was inaccurate. And so he put in a briefing and it had citations to cases that A, some of them didn't exist and B, of them were incorrect, had nothing to do. And he got busted. I think he was on his way to being disbarred. I don't know the full story. I'd like to see that. But he was supposed to do the analysis research himself. He just threw something together in ChatGPT, wrong references, submits that to court, confuses all the lawyers, and thank God the lawyers were reading it and going, really? What is he referencing? And the whole thing fell apart. And that's where you see it predicted what cases were relevant and so forth, but it wasn't relevant. And so I think relying on this incorrect information, I think is going to get us in trouble too as well. And then on one of my first podcasts, when I talked to Joshua Neal, who's a data scientist at Securonics, I used to know him when he was at Los Alamos Labs. And he was talking about how if you have enough bad data samples, you can actually teach a model that 7 plus 4 is actually 26. Because you just do it enough times, the model overrides its math logic, and that is the new answer for that. And I thought that was it's like gaslighting your AI here into the wrong answer. And so how do you prevent those? Like, how do you prevent your AI from getting bullied, so to speak, and having bad input like that? Wasn't there one that Google had that people were putting racist Nazi things in it and typing thing, and it started spitting out racist things?
I think that was Facebook a couple of years ago. It was like within 12 hours, it had become like horribly offensive. Yeah, one of the things that I think the Facebook example helped reinforce is that you can't just take anybody's input and allow that to be like unfiltered data that the model is training off of. I think the strategy that a lot of these companies is using is like human reinforcement learning, where they actually pay people to correct problems. So the theory is these aren't just random people, they're like part of your organization or really contractors to your organization that have a specific remit to correct incorrect responses. And then over time, when it's seen enough good data, it starts understanding how 2 + 2 = 4. Though it's important to know that it doesn't really know math, right? There's not a secret algorithm in there that's separately doing math. It just knows that it's seen enough times people reference 2 + 2 = 4. So
Really? I
it
thought
can
it would be a math function like you would in a code library where you're doing additions. It would just call a function and no, it
it's
just
literally
predictably guess it.
predicting the next best word.
Oh, that sucks. We had the app. Was it Visual Math or something like that? Where my kids showed me they would take a picture of a word problem. Now it had to be couldn't be handwritten math problem. It had to be from a textbook. You could take a picture of it and it would solve it for you, and then to show you how it got there. And it's supposed to be this learning tool, but it ended up being a cheating tool. So, are you
Well,
saying it
so I
doesn't
think
use
it's
math?
yeah, I think it's important to also understand that there's different applications and there's different types of models. A lot of what people talk about is the underlying model, but I think what's really more important is the higher level application. Like in our application, we have several models that are purposely doing specific, narrowly scoped jobs. And then we have other types of more traditional programming capability and like logic and stuff like that that also runs as well. So at the application layer, we use AI, but we're not using a single model to do anything and everything we would want it to do. And so in your example, you could build an application that uses computer vision that translates image to text. And then you could extract that text and then you could give that equation to a Python math module that then does the work, right? So the actual equation is being run by a program that was specifically based on mathematic rules. It doesn't have to be one type of model. And even if it was a language model that was doing the math, you would still need two models. You would need that computer vision model that's translating the image it's seeing to actual text that can then be pushed into further downstream models. The applications that we use in the future, right now, there's a lot of applications that are single model, very narrow purpose. The applications that we use in the future are going to rely on tons of different models that have different roles. And it's going to be the software that reconciles orchestrating all of those capabilities and functions together that then gets you the product output that you want.
Yeah, it's interesting. So I think we still have a long ways to go. And then what's the policies for AI when they come in? How do you maintain them? What's its beneficial focus at? I think we're all trying to get where we can find bad quicker, faster, better, especially in our threat hunting capabilities and so forth. I'd love to be able to have a bot that's my hunter bot and it just says, hey, I've been thinking about this. These are the different theories I've been going through. And I think I found something that we need to take a look at as I sift through these logs. The only problem is that just getting SIM, just like Splunk SIM going and just having correlation properly and just making sure we don't have parsing issues and just making sure that data element matches. Yet that all seems to be hard to get to actually work right as the infrastructure gets bigger and more complicated. Are we going to have a breakdown in AI at the same time? Its data sources aren't available, so it just makes stuff up, or what all you have to be connected to make that happen.
Yeah, this is where we think a lot about how can AI solve like the non-sexy problem. So specifically, could you use AI to normalize data? If you saw a log and you're like, that format sucks, it should be in this format, or you see a log come in and it's got different names for fields than you're used to using, could you have an AI reconcile that for you? And it's narrow task to do that particular work. And then there's a next step in the processing pipeline that does some other narrow piece of work. So I actually see it more of an opportunity, not necessarily to say, I'm going to, again, take one AI, one large model, and just give it some text and see what it spits out, but to say, I have these very discrete problems that have been really challenging, right? Garbage data. And it's another scale problem. If I had a person look at every log that came in, they could fix every log, right? But I'm not going to do that. But could I teach an AI the very narrow job of fixing my data as it comes in that way, solving for data normalization in a way that has never been possible with the rule set approach.
Yeah, because the rule set's using Yara to try and map different things out, and it's just always been complicated. And then the rule didn't catch this for some reason, especially when attacks are living off the land, where it's actual user activity, and RDP is normal, but not to those machines, and not in that way, and so forth. It just gets really complicated.
And you've seen all the issues, right? Like just with Windows event logs for a global organization, I've got a subset of logs that come in XML format. I've got a subset of logs that come in the more human legible format. I forget what they call that. Might have a subset of logs that come in German. And the analytics really struggle to deal with all of that. And you really have to have programmed your system to account for all of these things. But the AI can understand the intent of where you're trying to get to and can probably do a really good job of taking whatever shows up and translating it into whatever it needs to be to correctly be the input of the next step in the process.
Yeah. And you ask yourself, who's going to maintain these systems as we move forward? We got firewall administrators, you have SIEM administrators. We're really going to have AI administrators, and what is their task? To look through cognition results, cognition output. Hey, I made these five. Here's my biggest problem. I can see we have regulations in the banking industry on being able to look at loans for people, right? You can't have their race, religion, any of these factors used in determining somebody's creditworthiness. How do you, if you're going to start having mortgages and all processed by an AI, how do you prevent it from taking these different pieces of information in or not executing these decisions? It's almost like you're going to have some log of why it made that decision. How do you get to that kind of auditability where it said, based on this and this is why I made this decision? And because if not, we normally interview a human. We go, okay, human, why didn't you give Sally this loan versus this one, and so forth? You can walk through your steps. You can go through it. How does AI do that? How does AI walk through, hey, this is how my cognitive steps and how I came to this? Because I don't see it's having that ability to do that. Or am I wrong?
There are strategies, but at the root right now, it would be difficult to do it with any degree of certainty to figure out exactly what connective points were the things that made the final decision. And the reason is, when you have 17 billion parameters, right? Each of those parameters is one piece of the overall output of the answer. It's hard to stitch back together all of the connection points that it makes. And you bring up an interesting point, right? Like, how do you keep a model in that situation from indexing on somebody's race? You could just not give it the race, but there are other factors.
Yeah, it queried Google. It did this. It did that. It queried Google, saw an image of the person. All I'm saying is, you don't know what it's connected to or what the points are. So how can you go back and make sure its logic's right? Like they would talk about these two AI models that created their own language or protocol, and it was sending data back and forth. And that the scientists, and I don't know if this is a true story or not, but the scientists noticed that the two models, the two AI bots, created their own language that they never taught them how to do and could interpret and knew what they were saying. Really?
Yeah. I heard that too. I don't know what the context behind that was, but it certainly doesn't seem implausible that a machine could find a more efficient language than what we use. If you look at chess AIs, right, like they find more efficient ways to play chess than any person ever thought of. Why wouldn't it be the same with the rules of language? It could solve for inefficiencies in how we communicate for a particular purpose. So that doesn't seem unusual. I think, but it all just reinforces the point of there's a lot still to learn about how these systems are going to work and what are the rule sets around how they need to work. I don't think it's too different than how I've always felt about automation and this concept of the cost of being wrong. So when you give a workload over to a machine, I always think about not only what is the net benefit of a machine doing this job, but what is the impact if it is wrong, if it denies a loan that it should have processed, if it in cybersecurity decides to quarantine a host on its own or a whole fleet of hosts on its own, what is the net impact of totally having a human out of the loop? And if that cost isn't bearable, isn't something that you're willing to take on, then you need to either not implement that particular workflow or add some other circuit breakers in place so that somebody can stop a bad decision from having cascading impacts. And I think that's the same here. If you look at terms of service for all these like API based models, they explicitly say not to be used for, and then they list a bunch of industries. And I think one of them is always like mortgage lending, because I think they're particularly sensitive to what happens if somebody finds out that big bank X has been using ChatGPT to dole out loans, right? That is bad for everybody's
It
reputation.
violates some law and some provision and didn't follow regulations. And yeah, I could definitely see that. One of the other pieces that I think is just what jobs get replaced by that. I could see where there's call center agents that get replaced. It's just a bot. You think you're talking to one now in many ways when you call into some place and it automatically asks you to. That's more of an IVR system for voice response. It's not really AI driven. The craziest thing it'll do is that you're coming from the same phone number, how you doing, and so forth. But other than that, you really don't have dispute resolution for this. You still have to have people talking to people to figure out or why that bank transfer didn't go through, or why that didn't occur in that manner. So it still seems to be that kind of interaction.
Yeah, but when I hear about those things, and I'm sure that there's examples that I'm not thinking of, but I see a lot of jobs that either people don't necessarily want to be doing, or we just don't have enough people to do the job. And so when you say call center, my mind immediately goes to the horror story of people trying to get through to their airline because a big weather storm has shut down an airport and everybody needs to reschedule their flight. And it says your call will be answered in the next 8 hours because there's nobody on the other side of the phone. If an AI can do that job, all of a sudden that scale problem goes away and everybody can get a potential resolution to their problem immediately. And that feels net good. And so what we're doing is in the same space, right? There'll never be enough people to do the job that we're trying to do. And I think there's so many other needs for people in cybersecurity that I doubt that we ever displace anybody, because we're talking about how do you do more? How do you change the business model to be able to get value out of increased capacity in a job that is very people bound at the moment? And I think there's a lot of jobs like that. And those are the types of jobs, honestly, I think the AI slots into best.
I think you and I coming from Booz Allen Hamilton and the big enterprises. So we were used to doing acquisitions and mergers, helping these big oil and gas or pharma or whatever industry they're in transform their cybersecurity programs. But at the same time, they always seem to be several years behind the curve because some of these mergers are just trying to get through technical debt from years ago. And it's almost, I don't even want to think about AI because artificial intelligence is no match for natural stupidity. And if I see a lot of executives in some of these mergers try to make a monetary decision that says, okay, I see that 15,000 employee company we're going to merge into and we're going to onboard, but let's just keep all their hardware. Let's try to keep the same image. I know they have a separate proxy and firewall, but can we incorporate that so we don't have to replace it? And now I just have a mess of crap. I have multiple different firewall pairs I have to administrate, different EDR platforms. They don't integrate very well, but that executive who made that decision was able to save a few bucks on the merger, but cause us technical debt problems in the future for years. And you'll see how is it you can't even get through the replacement of old technology and your cycling of it. You're never going to use AI because your technological mentality for how do you develop your systems and their life cycle is not conducive to keeping up with an AI technology, which in my mind would need clean data sources, would need your ability to do things. Well, if I had 4 different EDR platforms and I can barely get the data back and they don't match up, how is AI going to be able to solve that problem? I'm almost
Well,
like setting it up to fail in many ways.
yeah, but I mean, if you think about what the underlying issue there is, it's difficult to manage for EDR platforms, right? Because I have a rule I want to deploy, but it works in 4 different ways and 4 different systems. Or think about the SIEM platforms, which are even more difficult. They all got different languages that have different strengths and weaknesses. And some analytics are easy and some analytics are difficult in different platforms. And that creates like a human issue because now a human has to be an expert in all of those things. But if you could give your intent to an AI that understood the rule sets, right? Could read the manuals on all of those systems and understand and recommend, hey, this is the configuration you should use in this system. This is the configuration you should use in that system. Here's where it talks about it in the documentation. All of a sudden, you can have a force multiplier that doesn't eliminate the complication and the impact of having multiple systems, but it eliminates some of the need for any one individual to be an expert in all of those things in order to be effective in working with them. And so those are, again, like the non-sexy problems that I think AI can really help solve. They can help scale what one person can manage because they can overcome the knowledge gap and the expertise gap with any particular tool by just being able to read the manual and then regurgitate information from it and use its understanding of intent to make bespoke recommendations on particular configurations. And I wouldn't trust somebody to go necessarily implement those things directly without reviewing them, but I certainly think it would be the force multiplier that helps solve for some of those issues.
Yeah, I think so. Now, tell me about North Carolina here. So you're really plugged into the area. We're both from the Charlotte area, but is this really a hotbed now of technology and things that are going on? So what have you been seeing in the North Carolina region just related to our industry?
In terms of technology,
Or just of events and things that are occurring? Anything?
so you have in Charlotte in particular, you have a lot of big financial services institutions and they have resources to spend, right? So I think that they've been spending on net new capability, but I don't have a great answer for you in terms of what's specifically happening here that people are really excited about. I
Seems to be
think
the
it's
same as the rest of the nation and nothing like really specific to North Carolina, right?
Yeah, yeah. It just in focus, right? You've got people protecting money, and then you've got a lot of like biotech people protecting trade secrets. And in both of those cases, you're really worried about insiders and fraud. And so, probably a lot of movement in this next generation of user risk capability. There's a lot of phishing platforms that are being transformed into user behavior modeling platforms so you can understand the risk associated with any particular individual, and then you can use that risk information to make other decisions. Maybe you do more MFA challenges for people who are likely to have bad password practices. Maybe you elevate security alerts related to people who have some particular type of profile. So there's a lot of that, I think, floating around in industry that I think would be really relevant to the core focus of what a lot of North Carolina businesses are trying to protect.
Yeah, it's interesting. And definitely a hotbed of technology between Raleigh and from Charlotte and so forth, really supporting the big organizations. And man, John, it's been great talking to you. I think we had a great conversation back and forth about the challenges with Salem Cyber's coming up. And are y'all going to any events coming up here soon? Or?
Yeah, so we're going to go to Triangle InfoSecCon in Raleigh, Charlotte Cyber Symposium, and I'm actually up in Winston-Salem. There's a little event here coming up in the next 2 weeks, a Triad InfoSec conference. There's a lot of great local cyber conferences and user groups. And yeah, so we're trying to get plugged into as many as we can. And it's been great. Something I never took advantage of when I worked at Booz Allen was just how strong the cyber community here is in North Carolina. And one of the unintended benefits of jumping out and starting a business is getting plugged in with all the great practitioners who live and work here.
It's a great environment for that. I'm looking forward. I'm building my new lab out too. I'm replacing older hardware and newer stuff, and so looking to get back on hands-on keyboard. So I'm thinking I'm going to do a podcast just on that, on how to build your own lab, how to have your own Azure instance for some things that you want to do to continue that learning. So hopefully that would be pretty exciting. And of course, I want to start doing the every year. I've applied to our RSA for speaking engagements there in Black Hat. Never one hasn't landed yet, but that doesn't mean I'm not going to continue focusing on that. Hopefully we get a few more speaking engagements, and then just creating good content for the podcast and trying to connect with other people. And so far so good. We're nearly at almost at 10,000 downloads for the show. So we're over
Wow,
6 months.
congratulations.
So I think we're at 9,300, something like that. And so when I cross the 10,000, it's this marker, and it's been an interesting ride so far. And this is the 6-month mark. But I really appreciate you joining us, John. It was a great discussion. Hope to talk to you again soon. And thank you.
Yeah, thanks, Josh. Thanks for having me.
All right, everybody, also don't forget to stay secure. Tune into the next episode that comes out every Tuesday at 12 o'clock Eastern on Voice America Network. Now, don't forget to hit like, subscribe, comment, share, and turn on those notifications so you don't miss an exciting episode.
Thanks for listening to this episode of Cybersecurity America on the Voice America Business Channel. We hope you've learned some valuable information to help you be a better executive leader and navigate today's complex world of cybersecurity. Until next week, stay secure.